Next type is linear differential equation. Define a linear differential equation and explain the method to solve it. So the differential equation of the form dy by dx plus pxy is equal to qx. What is px? Px is the function of x, purely function of x. And qx is again the function of x. So, or we can denote this px and qx as just capital P and capital Q. So the differential equation of this form, where p and q are functions of x alone, it's called a linear differential equation, where p and q are the purely or alone functions of x alone, that is independent of y. So this type differential equation of this form or reducible to this form are called a linear differential equation. Either the given differential equation of this form, or we can reduce the given differential equation to this form, are called linear differential equation. So this is the definition of linear differential equation or format of the linear differential equation. Now we have to define the method to solve the linear differential equation. Shortly, linear differential equation is denoted by LDE, linear differential equation, LDE, capital LDE, linear differential equation. So consider linear differential equation dy by dx plus pxy is equal to qx. Suppose this is number one, equation number one. Now we have to solve this differential equation or method to solve the linear differential equation. So dy by dx is equal to qx minus pxy. Shift this quantity to RHS, then shift this dx to RHS. So it's multiplied to this bracket, and then dy minus shift this quantity to LHS, qx minus pxy dx is equal to 0, or we can write px minus qx. So this, after this negative sign here, so we have this pxy as positive and minus qxy dx and plus dy is equal to 0. Suppose this is equation 1, this is equation number 2. So this given differential equation is expressed in the form m dx plus n dy is equal to 0. So compare with m dx plus n dy is equal to 0. So m is pxy minus qx and n is 1. And then find dy m by dy y. Dy m by dy y is px is now constant. The derivative is with respect to y, means the quantities of x are constant. So px is constant, derivative of y is 1. And derivative of qx is 0 with respect to y, because qx is purely function of x alone. And so its derivative with respect to y is 0. And dy n by dy x, n is 1. So derivative of constant 1 with respect to x is 0. And so what is your observation? Dy m by dy y is not equal to dy n by dy x. And therefore this equation 2 is not exact differential equation, because dy m by dy y is not equal to dy n by dy x. But we can find the integrating factor of this equation number 2 by using this formula. Dy m by dy y minus dy n by dy x divided by n is equal to what? Dy m by dy y is px minus dy n by dy x is 0 divided by 1 is px is function of x alone, and therefore the integrating factor is e raised to integration. Suppose suppose this is fx, then integration fx dx, that is e raised to integration px dx. So this is the integrating factor, and this is now this is the integrating factor is find integrating factor here obtained by using one of the rule of finding integrating factor. There are 5 rules. In all there are 6 methods, the inspection method, and 5 rules to find the integrating factor, to obtain the integrating factor. So one of the rule is applicable here to obtain the integrating factor. So we have the integrating factor. When we it is the integrating factor. Why it is the integrating factor? E raised to integration px dx is integrating factor, because this dy m by dy y minus dy n by dy x divided by n is the function of x alone, and therefore integrating factor is e raised to integration px dx is the integrating factor. And then multiplying equation 2 by the integrating factor, this so what we have, this is the equation number 2. So pxy minus qx dx, so multiply by e raised to integration px dx to the equation second. So what do we have? E raised to integration px dx in bracket pxy minus qx dx plus e raised to, again here multiply by e raised to integration px dx dy is equal to 0. So crash this. Equation second becomes, this is the equation second. So multiplying equation second by integrating factor, that is e raised to integration px dx. So we have this differential equation, and this is the exact differential equation. This is now exact differential equation. Suppose denote it equal to it by 3, number 3. Then this is the exact differential equation, because this integrating factor, after multiplication of integrating factor, we know that the given non-exact differential equation converted to exact differential equation. So this is the definition of integrating factor. After multiplication of integrating factor, the given not exact differential equation converted to exact differential equation. So multiplying the equation 2 by e raised to e integration px dx, that is integrating factor, this equation becomes exact differential equation. And then its solution is, that is the solution of actually 1. Then its solution means solution of this equation, means solution of second, and means solution of 1, because 1, 2, 3 are equivalent differential equations. And therefore its solution, then its solution, that is the solution of 1 is, the formula is what? To obtain the general solution of exact differential equation, formula is integration m dx plus integration terms in n independent of x dy is equal to 0. And that is integration, and m is e raised to integration px dx. M value of m is e raised to integration px dx in bracket pxy minus qx is, now this is m, the coefficient of dx, and plus terms in n independent of x. There is only one term in n, this is n now, and in this term is depend on x, so 0 dy. There is no term independent of x in n, so 0 dy is equal to c, constant of integration, right here c, not 0, is equal to c. And now split this e raised to multiply this e raised to integration px dx in bracket, we have this, and then split the integration, that is integration of subtraction is subtraction of their integration. So integration e raised to integration px dx pxy dy minus dx minus e raised to integration px dx qx dx is equal to constant, and shift this negative quantity to RHS, this side to RHS, we have this. And then put integration px dx is equal to t. Why to solve this integration to LHS? Where to solve this integration? So substitution integration is by using substitution. Substitute integration px dx is equal to t in LHS. So we have its derivative of this quantity is what? Derivative and integration get cancelled. So we have px dx is equal to dt. Okay. So differentiate both sides with respect to x. We differentiate both sides with, we have px dx, integration and derivative get cancelled, and is equal to dt. And then this y is now constant quantity. Integration is with respect to x, so take y as outside the integration, and then e raised to t, integration px dx is denoted by t, and px into dx is dt. Okay, and take this y outside the integration, is equal to this side as it is, integration e raised to integration px dx qx dx. Okay, this side as it is plus constant, and then e raised to t integration is e raised to t, integration of e raised to t with respect to t is e raised to t, is equal to this side as it is, and then substitute t as integration px dx. So y e raised to integration px dx is equal to qx integration qx e raised to integration px dx plus constant. Okay, or if we denote e raised to integration px dx as I, integrating factor I, then the general solution is what? yi is equal to integration qi or qxi dx plus constant. So this is the general solution, this or this. So is the general solution of the given differential equation. So this is the formula to obtain the general solution of the linear differential equation. What is the formula? yi is equal to integration qi dx plus constant. What is I? I is e raised to integration px dx. So this is the formula and this is the method to obtain the general solution of the given linear differential equation. So this is the formula. Now how we can obtain the, so this is the formula to obtain the general solution of the linear differential equation. So we solve the this is the another form, dx by y plus pyx is equal to qy. Instead of x, we write y, and in place of y we write x. So this is the another form. And so what is its solution now? What is the solution of this form? In replace in this solution, replace x by y and y by x. So the answer of this problem is, the solution of this type linear differential equation is what? So right here, xi is equal to integration qy I dy plus c. And what is I? I is equal to e raised to integration py dy. So right here is the answer of solution of this differential, this type linear differential equation. So problem on the linear differential equation: solve 1 plus x square dy by dx plus 2xy is equal to cos x. Actually this is not in the form of that this form, that dy by dx plus pxy is equal to qx. So the differential equation is, the given problem is not always in that form. We have to reduce that problem in that form. So dividing by 1 plus x square throughout. So we have dy by dx plus 2x divided by 1 plus x square y is equal to cos x divided by 1 plus x square. And this is a linear differential equation of the form dy by dx plus pxy. What is px? 2x divided by 1 plus x square is px. Is equal to qx. Qx is what? Cos x divided by 1 plus x square. So this is the linear differential equation of this form. And so we will find first integrating factor. So integrating factor I is equal to e raised to integration px dx. This is the formula to obtain the integrating factor. So I is equal to e raised to integration, what is px? 2x divided by 1 plus x square dx. And this is in the form integration f dash x divided by fx. What is the integration of f dash x divided by fx? Is log fx. So it is integration of 2x divided by 1 plus x square is log 1 plus x square, e raised to log 1 plus x square. And then e and log get cancelled, so we have 1 plus x square as the answer. E raised to log 1 plus x square is 1 plus x square. So this is the integrating factor. Suppose denoted integrating factor by I. And then the solution of the given linear differential equation is, the general solution of the given differential equation is, what is the formula? yi is equal to integration I into qx dx plus c. So this is the formula, yi is equal to integration qx into I or I into qx dx plus c. So write that formula, substitute the value of I, that 1 plus x square is equal to integration 1 plus x square I. Value of qx is what? Qx is cos x divided by 1 plus x square, dx plus constant, 1 plus x square get cancelled. So integration cos x dx, and integration of cos x is just sin x plus sin x. Okay. So y in bracket 1 plus x square is equal to sin x plus c, or we can write y in bracket 1 plus x square minus sin x is equal to c. This is the general solution of this differential equation. So in order to obtain the general solution of linear differential equation, we have to find first integrating factor I. What is the formula for I? E raised to integration px dx. And then the solution of the given differential equation formula is what? yi is equal to integration I into qx dx plus constant. So next example, 1 plus x divided by dx minus 1 plus 2xy is equal to x square 1 plus x square. So dividing by 1 plus x, we have dy by dx minus 1 plus 2x divided by 1 plus xy is equal to x square root 1 plus x divided by 2 into 1 plus x. And so this is the linear differential equation of the form dy by dx plus pxy is equal to qx, where with px is what? Px is minus in bracket 1 plus 2x divided by 1 plus x, and qx is this x square root 1 plus x divided by 2 times 1 plus x. And then we have to find the integrating factor. This is linear differential equation. So we have to solve this linear differential equation by using the method, that is first find the integrating factor The formula is I is equal to e raised to integration px dx, is that is e raised to minus 1 plus 2x divided by 2 1 plus x, the value of px, substitute value of px, and that is minus 1 half. Take this 2 outside the integration, so minus 1 half integration 1 plus 2x divided by 1 plus x dx. And in order to find the integration of 1 plus 2x divided by 1 plus x, we have to factorize this. We have to reduce this in partial fractions, in that partial fractions. So the adjustment is write this add 1 and subtract 1. So we have 1 plus 1 is 2 plus 2x minus 1. If you simplify this, 2 minus 1 become 1 plus 2x. So write 1 plus 2x, value of 1 plus 2x as 2 plus 2x minus 1. Then take 2 common from the first two terms, and we have 2 in bracket 1 plus x divided by 1 plus x minus 1 divided by 1 plus x. So split in the two parts, 2 plus 2x divided by 1 plus x and minus 1 divided by 1 plus x. So dividing this 1 plus x separately to this factor first, take 2 common, and so we have 2 minus 1 divided by 1 plus x. So this is the factorization of this division in order to find the integration. And now integration is this minus 1 half quantity as it is. So we have integration is 2x. This is the integration. Integration of 2 is 2x, and 1 by 1 plus x is integration is log 1 plus x. And so now integrating factor is, write I is equal to, first write integration, don't write this minus 1 half. First write is equal to, after this step write is equal to 2x minus log 1 plus x. And then integrating factor is what? I is equal to e raised to minus 1 half. Integration of this quantity is now in bracket, right? 2x minus log 1 plus x. And so it is e raised to multiply by this minus 1 half in bracket. So minus e raised to minus x plus minus become plus 1 half log 1 plus x. So this is the integrating factor. And now obtain the general solution by using the formula. After integration factor, we obtain the general solution. Write the general solution by using the formula. Yi is equal to integration I into qx. Yi is equal to integration I into qx dx plus constant. So write that formula and find the integration. So these are the problems for homework. There are in all 8 problems on this type. 8 problems on this type. Linear differential equation. So solution of the third number problem. Solution of the third number problem. This is the solution of third number problem. First number problem, it is incomplete this solution. So we have to solve all these differential equation by using the answer of some problem is given. So observe this example number 2. Dx plus x dy is equal to e raised to minus y sec square y dy. Example number 2. This dx plus x dy is equal to e raised to minus y sec square y dy. So this is the, we have to first identify that this is the linear differential equation. That is very critical job. That is, we have to first identify that it is a linear differential equation, and then we have to reduce the differential equation in the form, linear differential equation in the standard form. What is the standard form? Dy by dx plus pxy is equal to qx, or the another form is what? Dx by dy. Instead of dy by dx, dx by dy, pyx is equal to qy. So now this is the differential equation of that type. This differential equation is not dy by dx, it is dx by dy. So dx is equal to, shift this quantity to RHS, x dy, take dy common, and take then dx, shift this dy to LHS. So dx by dy is equal to e raised to minus y sec square y minus x, and so dx by dy, shift this minus x to LHS. So plus x e raised to minus y sec square y, and is linear differential equation of the form dx by dy plus pyx. What is py? Py is 1 into x is equal to qy. Qy is this. So py is 1 and qy is e raised to minus y sec square y. So this is the another form, and so we have to find first integrating factor. Now this is the linear differential equation. So now we have to find integrating factor. So what is the formula for integrating factor? I is equal to e raised to integration py dy instead of px dx. Now we use the formula integration py dy. And what is p? P is 1. Don't write here dx dy. And the integration of 1 with respect to y is y. 1 into y, that is y. E raised to y. Don't write here dx. It is dy. So integration of 1 with respect to dy is y. Integration of 1 with respect to dx is x. But it is not dx, dy, right? Dy. So this is the integrating factor. Now now the general solution of the given differential equation, right? Here sentence. Therefore, the general solution of the given differential equation is, the formula is what? Instead of yi, write xi is equal to integration. Instead of qx into I, write qy into I dy plus constant. Qy into I dy constant. Replace x by y and y by x. So x e raised to y, integrating factor is e raised to y, is equal to qy. What is qy? Qy is this e raised to qy. What is qy? Qy is e raised to minus y sec square y. Substitute that qy, and I is e raised to y. Dy is equal to constant. So e raised to minus y and e raised to y become e raised to 0 means 1. So we have just integration sec square y dy. And the integration of sec square y with respect to y is tan y, because derivative of tan y is sec square y. So x e raised to y is equal to tan y plus constant is the general solution of that differential equation number 2. So similarly, this is the answer of equation number 1. Cosec square x dy by dx. Cosec square x number 1. This cosec square x dy by dx plus y plus cos x. So we had to reduce the differential equation to linear differential equation format. So dy by dx, so shift this cosec square x to RHS or divide throughout by cosec square x. So divide by cosec square x means multiply by sine square x. 1 by cosec square x means sine x. So sine x into y plus sine x into cos x. So multiply, divide by cos x to RHS means multiply by sine x. So we have sine x y, y into sine x, or right, sine x into y, and then sine x into cos x. And then dy by dx minus sine x into y, right, sine x in bracket and then y, shift this quantity to LHS, is equal to sine x cos x, this as it is. And this is linear differential equation of the form dy by dx plus pxy is equal to qx. What is px? Px is minus sine x and qx is sine x into cos x. So this is the linear differential equation. This given differential equation is linear. We have to reduce this linear differential equation to its standard form. What is the standard form? Dy by dx plus pxy is equal to qx. Or another standard form of linear differential equation is what? Dx by dy plus pyx is equal to qy. So px is minus sine x and qx is sine x into cos x. So I is equal to integration px dx, that is e raised to minus integration sine x dx, because px is minus sine x, and integration of sine x is minus cos x. So minus minus become plus cos x. So e raised to cos x is the integrating factor. And now the general solution of the given differential equation is what? The formula is yi is equal to integration qx into I dx plus constant. So this is the formula to obtain the general solution of linear differential equation. So substitute I as e raised to cos x, qx as sin x into cos x, e raised to cos x dx plus constant. And then we have to solve this integration by using substitution. So put cos x is equal to t, and therefore its derivative is minus sin x dx is dt, means sin x dx is minus dt. So substitute. So y e raised to, don't substitute in LHS, cos x is equal to t. Remain this y e raised to cos x as it is. No need to substitute cos x as t in the LHS, because it is for to solve the integration on RHS. This substitution is used to obtain the integration of this RHS. So write y into e raised to cos x as it is, LHS as it is equal to this cos x means t, and e raised to cos x means e raised to t. And this sin x into dx, the value of sin x into dx is minus dt plus constant. So take this minus outside, t into e raised to t dt, and the integration is by using part rule. This integration is by using part rule. T is algebraic function and e raised to t is exponential function. So t is the first and e raised to t is the second, and so minus this minus sign as it is in bracket, right, in bracket the part by using part rule. First, that is t, integration of second e raised to t, integration is e raised to t, minus integration of second is again e raised to t, into derivative of first is 1 dt plus constant. Okay, so this is the part rule. What is the part rule? First integration of second minus integration of second derivative of first plus constant of integration. And then after negative effect of this negative sign, we have this term is negative, this term is positive, and integration of e raised to t is again e raised to t plus constant, and substitute t as cos t. So y is equal to e raised to cos x, y into e raised to cos x is equal to minus cos x, t means cos x, e raised to cos x into e raised to cos x plus e raised to cos x plus constant. And this is the general solution of the given differential equation. So these are some problems for homework. Here the initial condition is given. So first obtain the solution of this differential equation and then use this condition. So what is the condition? Y1 is equal to 1 means what? Y is 1 if x is 1. So substitute x is equal to 1 and y is equal to 1 in the solution of this differential equation. So in the final answer, and find the value of c. We have suppose we have this, and this is the answer. And the condition, initial condition is given, that is y1 is equal to 1. Y1 is equal to 1 means what? Y is 1 if x is 1. Or y1 is equal to 2. Suppose y1 is equal to 2. Then y is 2 if x is 1. So substitute y is 2 and x is 1 in this and find the value of c. And resubstitute that value of c at this place in the general solution. We get the particular solution. So these are the problems for homework on linear differential equation. So I will share some more problems on linear differential equation for practice. So the last type of this paper, now the equation reducible to linear differential equation, that is the Bernoulli's differential equation. We will see this type in the last lecture. So this is the last type. Actually there are 6 types. So what are that? Basic 3 types. So first type is what? Variable separable. The second type is reducible to variable separable. The third type is homogeneous differential equation. Fourth type is reducible to homogeneous differential equation. Fifth type is exact differential equation. Then sixth type is reducible to exact differential equation. Then seventh type is linear differential equation, and this is the 8th type now, reducible to linear differential equation. In all, there are basic 4 types. First is variable separable, second is homogeneous differential equation, third is exact differential equation, and fourth is linear differential equation. And in each type, there is a subtype. So in the first type, variable separable, then reducible to variable separable is its subtype. The second type is homogeneous differential equation. Its subtype is reducible to homogeneous differential equation, or is called non-homogeneous differential equation. The third type is exact differential equation. Its subtype is differential equation reducible to exact differential equation. And the basic fourth type is what? Linear differential equation, and its subtype is what? Reducible to linear differential equation, or is called also Bernoulli's equation. So this is the last type of this paper. So we will see this type in the next lecture.